Okay, so last talk of the session on user energy interaction, and this talk is about the effect of displaying kinetic energy on hybrid electric vehicle drivers' evaluation of regenerative braking. So quite a long title, hopefully not too long talk. So let's start. So let's start with a question. So what would you say? What's the key difference between a conventional combustion vehicle and an electric vehicle in terms of user energy interaction or energy dynamics? So just think about it. What would you say if someone would ask you? So I would say that a key difference is the bidirectional energy flow in electric vehicles. So why is it, or what do I mean with this? Let's start with a conventional vehicle. So in a conventional vehicle, you could say you have a certain amount of fluid gasoline in your fuel tank, right? And now what happens is when you want to accelerate, you pump this fuel drops into the motor, they are burned, and they produce kinetic energy, that is movement. But the bad thing is that once you have burned these drops of fuel, you can never have them back. So there's no way the fuel will ever come back into the fuel tank. And so you could say your energy resources are a monotonously decreasing function. And that's why you could say it has a unidirectional flow of energy resources in a conventional vehicle. The EV, the electric vehicle, is different. So in the electric vehicle, of course, you have, first of all, a certain amount of, let's say, charged electrons in your tank, or let's better say, battery. And now if you want to accelerate again, then we have a pattern that these electrons are pumped into the electric motor to be converted into kinetic energy, that is movement. Now, the difference is that here, when you decelerate, the electric motor runs back to produce from the movement these small little charged electrons and puts them back in the battery. So it's no goodbye forever. If you lose your little electrons in an electric motor, you can regain them in regenerative braking. And so you could say, first of all, the energy resources will not just go down, but they will fluctuate, and there's a bidirectional energy flow of energy resources. Now, interesting question, what does that mean? So, how do drivers interact with this bidirectional energy flow, and will they develop the correct mental models of energy gains and energy losses, and consequently, will they develop efficient eco-driving strategies? So this was an interesting question for us, one of the key questions of a study we did with about 120 hybrid electric vehicle drivers. So important thing, we did not just have electric vehicle drivers, but hybrid electric. And as you can see here in the video, hybrid electrics are even more complex, because there you have a combustion engine and an electric engine working together in a highly dynamic fashion. So you might say, okay, no one will ever understand this, no one will ever learn an eco-driving strategy, but that's not the case. So people also in hybrid electric vehicles, they develop mental models of energy efficiency, and they develop their strategies. And one thing that we learned was that they learn, or that many drivers have a tendency to perceive actively gathering and utilizing the electric energy as very efficient and drive accordingly. For example, question, would you use the regenerative braking as often as possible, or would you rather try to use regenerative braking as seldom as possible? So drivers in our sample said, yeah, many drivers favored regenerative braking. But the interesting thing is when we correlated this with actual fuel efficiency or energy efficiency data, this tendency was actually related to a less fuel efficient strategy. So it seems, and if we think about it, it also becomes clear that regenerative braking, so intensive regenerative braking, is not a good idea. It's not energy efficient. For example, because only part of this kinetic energy that you regain can be actually regained and used later on, because there are lots of energy conversion losses. And that's not the only thing. The other thing is more on a global temporal level, that if you are always thinking, okay, it doesn't matter if I decelerate too much or if I make an additional acceleration, that's not possible, not necessary, because I can regain the energy. But actually you cannot. So it seems that many drivers are somehow aware of the energy gains, clearly, but they are not really aware of the energy losses of regenerative braking. But we then realized that's not their fault. That's more the fault of the energy interface, because many energy interfaces in electric and hybrid electric vehicles do it something like this. So you see some energy flows, and if you accelerate, there goes energy from motor, battery to the wheels, and if you decelerate, same kinds of arrows, same force, same speed, same width, go back to the battery. So intuitively, what should I expect then? Everything that goes out comes back in again. So we started with thinking, okay, that's a very, very simple point to change. So why not try to make another framing? And so here we have the link also to our first talk, because here we have energy dynamics, energy resource dynamics, and people are deciding for certain energy gains and losses, or perceive certain energy interactions as efficient. But actually the framing in the display is very narrow. There's only part of the energy dynamics represented in the interface, and seemingly it's not enough. So one thing where we could add to this is showing also kinetic energy. Because what you do is, when you decelerate, you have built up kinetic energy with a lot of primary energy, so here mostly typically fuel. And so that's very precious. But there's no way you are seeing that you have this precious kinetic energy, apart from perhaps thinking, okay, speed is precious, and because it's very, of course, kinetic energy is very closely related to speed. So we thought about, why not add something like a kinetic energy battery as a very first idea to this interface, and also show that if you decelerate, this kinetic energy isn't one-to-one put into the battery, but there are losses, energy conversion losses. And this might also help then that people do not anymore view the regenerative braking as very efficient, but rather tend to perceive neutral mode, so neutral gliding, as more efficient. So what is neutral gliding? This is actually if you are in a certain... So I can tell, for one example, hybrid electric vehicle, there it is, you go from the gas pedal, you push the gas pedal a very little bit so that no energy is regained and no energy is consumed. So it's a neutral state without energy flows. And actually, this is what you can see on the top right, what typical energy interfaces show you. They show you nothing. They show you, yeah, there's nothing happening. But actually, it should be that you see the gains when you are in neutral mode, meaning kinetic energy only goes to the wheels, very purely, very efficiently. This is a very, very first idea how you could visualize kinetic energy, and there are lots of things that are not really good, but it's a starting point. And so we said, let's put this first starting point to an empirical test. So can we actually change hybrid electric vehicle drivers' energy efficiency perception by changing the salience of gains and losses in the energy flows? So we had basically two hypotheses. First of all, that the regenerative braking should be evaluated less positive for an energy flow display in which kinetic energy is made more salient compared to the conventional display. So conventional display above, adapted display with the added kinetic energy. And second hypothesis, the neutral mode should be evaluated more positive for an energy flow display in which kinetic energy is made salient compared to the conventional display. And we did this in an online study with 41 HEV drivers, mostly male. This is mostly the case, so it's still quite, at least in Germany, still quite an unequal gender distribution. 47 years, also quite typical for this population, and all had quite a good experience, or had considerable driving experience with their HEV. Okay, to assess this perceived energy efficiency, we had two scales. First of all, or more or less they are very closely related, so you just have to read the first items. So perceived energy efficiency of using regenerative braking. So maximum utilization of regenerative braking enables fuel-efficient driving, or less one deploys regenerative braking, the more fuel-efficient, so reverse-coded. And the same for the neutral mode. And this brought us in a position where we could test how the energy efficiency is perceived under the scenarios that different interfaces are presented. This is a within study. So first what we can see is that in the basic scenario, so almost the same display as they have in their current hybrid vehicle, there definitely regenerative braking is perceived more efficient as neutral mode. And regarding the hypothesis, because these were the actual tests, indeed regenerative braking goes down. So you have it here, 4.48 versus 3.59. And in neutral mode, you see here, it goes up, as expected. So both of these hypotheses were confirmed in this first study. So what can we take from this? First of all, we can say that indeed drivers evaluated regenerative braking energy efficiency higher than neutral mode energy efficiency in the baseline condition, you could say. That's more or less what we already found in earlier studies. Second, the salience of the kinetic energy in this energy flow display indeed reduces this unwanted positive evaluation of the regenerative braking. That means that you could say, if you formulate it from a more general perspective, that indeed it seems that the current energy flow displays do not optimally frame HEV eco-driving. That also important to see here that indeed it seems that HEV drivers draw their conceptualizations of the HEV's energy efficiency from the representations they see in the energy display. And finally, you should look, if you design such interfaces, for more complete framing of energy flows. Or at least you have to be really careful to get the energy dynamics that are necessary to get the right gain and loss framings, to really support eco-driving efforts. Of course, there are limitations, and I would say we should say it's really a first online study, because we need to go in the field to do real-life, everyday driving field studies, field experiments, and we are just about to doing this. So this is a possibility. I made this video, or I uploaded this video this morning. Here you can see the nice little village of Wolfsdorf near Lübeck, where our university is situated. And so you can say here, Toyota Prius, you can see now green means it's a neutral mode, so we have a very long glide. It's a flat street, so you can really get also a feeling of how long such a glide lasts. So it's like from 50 down to 40. Now we accelerate again, and it goes on for quite a while. So this is basically, we have set up the environment that we can now develop energy interfaces and test them in real life and give this app away to other people to be able to try different kinds of energy interfaces. That's it. Thank you for your attention.